Welcome back to my channel. Today we have to discuss the last part of the chapter heat and temperature, and our last part is known as coefficient of expansion. So means we have to discuss the different terms related to the expansion. Then first we have to discuss what is expansion of solids. Okay, expansion of solids. Solid substance show the following types of expansion when it is heated. When you are going to heat a solid substance, the following expansion will be, you can see the following expansion. One is linear expansion, and second one is superficial expansion, and third one is cubical expansion. Okay, we have to explain the individually. So first one is linear expansion. Okay, first one is linear expansion. When a solid is heated, its length will increase. This is called linear expansion. So what is that? When a solid is heated, its length will increase. This is called linear expansion. It depends upon material original length and change in temperature. Okay, linear expansion will depends on material original length and change in temperature. The next term is coefficient of linear expansion. The coefficient of linear expansion is the changing length per unit original length per degree rise in temperature. Okay, so coefficient of linear expansion means, the definition is that the coefficient of linear expansion is the changing length per unit original length per degree rise in temperature. It is represented by alpha. Then coefficient of linear expansion represented by letter alpha. Then there is a one equation for the linear coefficient of linear expansion. So just how to derive that equation. Length of the solid at T1 degrees Celsius is L1. Length of the solid at T2 degrees Celsius is L2. Change in temperature T2 minus T1. T2 is the temperature at with the length L2, and T1 is the temperature at with the length L1. Changing length means L2 minus L1. Okay, so our definition is alpha is equal to, what is the alpha? Changing length. Changing length means L2 minus L per unit original length. Original length means L1. Okay, that is the L1 into length and degree rise in temperature. Rise in temperature means change in temperature, that is T2 minus T1. So L2 minus L1 divided by L1 into T2 minus T1. That is known as alpha. So when you are changing T2 minus T1 is equal to T, the equation will be L2 minus L1 divided by L1T. L1T equal to T2 minus T1. Okay, that definition you have to understand. What is the definition? Coefficient of linear expansion is equal to changing length per unit original length per degree rise in temperature. L2 minus L1 divided by L1 into T2 minus T1. That is coefficient of linear expansion. Changing length divided by L1. What is the original length into changing temperature? Changing length divided by original length into changing temperature. So when you are finding the some question, you have to ask what is the change in length, increased length. What is L2 minus L1 is equal to alpha into L1T, alpha into L1T. That is a equation coming from this basic equation. L2 minus L1 is equal to alpha into L1T. Final length means L2 is equal to, when you are rearranging this equation, L2 will be equal to L1 will go into the right side, and L1 will be common. So 1 plus alpha T, that will be the L2. Okay. Next one is superficial expansion. Superficial expansion. There is a three type expansion is there. One is linear expansion. Second one is superficial expansion. Third one is cubical expansion. The linear expansion we are discussed here. The coefficient of linear expansion is the alpha. Then alpha equation is equal to alpha equal to change in length divided by original length into change in temperature. The next expansion is superficial expansion. When a solid is heated, its area increases is called superficial expansion. When a solid is heated, its area will increase. This is called a superficial expansion. Means expansion of the area when it is heating. This is known as superficial expansion. The next coefficient of superficial expansion. The increasing area per unit original area per degree rise in temperature. The increasing area per unit original area per degree rise in temperature, and it is represented by the letter beta. Okay, Then one relation between superficial expansion and one relation between superficial expansion, linear expansion. What is the superficial expansion is equal to 2 into linear expansion. Beta is equal to 2 into alpha. This is an important equation. Beta will be equal to 2 into alpha. 2 into alpha. So first one is the change in length per unit original length into rising temperature. Here will be increasing area divided by unit original area divided by degree rise in temperature, and beta will be equal to 2 into alpha. The next one is cubical expansion. When a solid is heated, its volume is increases. It is called cubical expansion. So when a substance is heated, the volume will be increased. That increase or expansion is called cubical expansion. The next one is coefficient of cubical expansion. The increase in volume per unit original volume per degree rise in temperature. Here volume, first one is length, second one is area. Here will be volume. Only the term will be changed. Increase in volume per unit original volume per degree rise in temperature. Per degree rise in temperature is a common for all the equation, and it is represented by the letter gamma. Okay, represented by the alpha gamma. First one is alpha, second one is beta, third one is gamma. Coefficient of cubical expansion is equal to 3 into linear expansion. 3, what is a linear expansion? It is a alpha. So gamma is equal to 3 into alpha. Okay, first one is alpha, second one is beta. Beta is equal to 2 into alpha. Third one is gamma. Gamma is equal to 3 into alpha. Okay, definition will be same, but only the volume. First one is length, increasing length. First one is increasing length. Okay, changing length. Second one is changing increasing area or changing area. Third one is changing volume or increasing volume. So first one problem here is this, we have to discuss that. If an iron bridge is 100-meter long at 0 degrees Celsius, what will be the length of the bridge if the temperature is 40 degrees Celsius and the coefficient of linear expansion is 12 into 10 raised to minus 6 per degree? So what is the initial length? It is 100 meter. Increase in temperature. Increase in temperature means 0 degree. First one is a 0 degree. Second one is 40 degree. Increasing T2 minus T1. 40 divided by minus 0. 40 minus 0 is equal to 40 degrees Celsius. What is the coefficient of linear expansion equation? You know, change in length. Increasing length divided by initial length into increased temperature. So you have to find the what is you have to find increasing length. You have to find coefficient of linear expansion is given, that is at 12 into 10 raised minus 6. Increasing length you have to find what is the initial length. Initial length is equal to 100 meter, and the changing temperature will be 40. So 12 divided by the 12 into 10 raised minus 6. So you have to find the increasing length. So it will be changed to right side. 12 into 100 into 40. 12 into 100 into 40. 12 into 100 into 40. 10 raised minus 10 raised to minus 6. When you are going to 10 raised to 6 will be each other. So it will be, it's a numerator. When you are going to the denominator, it will be plus 6. So you can see that 10 raised to 6, that will be this value. Okay. So increased length you have to find. So this term will be going to the this side. 12 into 10 raised to minus 6 into 100 into 40. So 12 into 100 to 40. 10 raised to minus 6. First one is numerator. You are going to the denominator will be divided by 10 raised to 6. That will be 10. Will do is with the 60. Okay. So it value will be 0.048 meter. Increased length is equal to 0.048 meter. So iron bridge at 40 degree. So first one is a 100 meter. Changing length is 0.048 meter. The total length after 40 degree will be 100.04048 meter. 100.048 meter after the 40 degree. One more question is there. Okay, the length of the metal rod is 100 centimeter at 30 degrees Celsius and 100 and 100.14 centimeter at 100 degrees Celsius. So 30 degrees Celsius 100 meter, 100 degrees Celsius is 100 and 14. Calculate the coefficient of linear expansion and the rod length at 0 degrees Celsius. Two question is there. First you have to find the coefficient of linear expansion. Then you have to find the rod length in 0 degree. So what is the initial length? 100 centimeter. Final length is equal to 114. Increased length, what is the 14? This minus this one, you will get the increase in 0.14. Increased temperature is equal to 100 minus 30, it is 70 degrees Celsius. So what is the coefficient of linear expansion? Increased length. What is the increased length? 0.14 divided by initial length. What is initial length? It is 100 degree and sorry 100 meter, 100 centimeter. Then what is the increased temperature? Increased temperature is 70 degree. Okay. So 0. When you are multiply by numerator and denominator 100, here will be 100, here will be 100. 100 means 0.14 into 100 will be 14 आता है. Okay. Each one denominator 100 will be there. Okay. Both the numerator and denominator multiplied by the 100. When your multiply here is 100, it will be 40 divided by 100 into 1700. 2 by 1 lakh will be there. Okay, it is equal to 2 into 10 raised to, and it is the numerator 2 into 10 raised to 5 is there. So when you come to upper numerator, it will what will happen? 2 into 10 raised to minus 1. That is will be the coefficient of linear expansion. Then you have to find the what is the rod length at 0 degrees Celsius. Okay, so that time you have to equation L1 and L this equation that will already be studied here. This one, this will be your L2 is equal to L1. That will be you can arrange. Okay, though L1 is the final initial length is 100 meter is equal to L0. L0 means length at 0. You have to find the length at 0. Okay. Then 1 plus alpha. What is the coefficient of linear expansion? It is 2 into 10 raised to 5 minus 5 into change in temperature. Change in temperature will be 30 degree. Okay. Change in temperature will be 30 degree. Means when you are converting 30 degree is 100 meter. 0 degree what will be the length? So 0 and 30 degree what is the difference? Is the 30 degree. So 30 degree. So 100 is equal to L0 into 1 plus it will be 0.0006. So L0 it will be 100 by 1 plus 0.0096. It will be 99.94 meter. Okay. So you have to do this problem. Okay. Otherwise it will not get the correct answer. Okay. You have to practice the problem. It will be not meter. It is a centimeter. It's a centimeter, not meter. Okay. The next one term you have to discuss is quantity of heat needed for a substance to rise the temperature. So what is the heat needed for a substance to rise the temperature? This definition you already studied. The amount of heat needed for heating 1 kilogram of the substance through 1 degree Celsius is equal to the specific heat of the substance S. For heating mass of m kilogram of the substance to attain the temperature difference of T, the quantity of heat needed, this equation we needed, Q, the quantity of heat needed is equal to m into S into delta T. M is the specific heat of that material. Sorry, m is the mass of the material, S is the specific heat of that material, delta is the what is the temperature, delta T is the what is the temperature difference. So heat needed to rise the temperature from T1 to T2. So to another temperature for a particular mass m of the specific heat S, what is the value? Ms delta T. Mass into specific heat into change in temperature. That will be the amount of heat. The next one is when you are two liquid you are mixing, what will happen? When there is an exchange of temperature, there is an exchange of heat. When there is an exchange of temperature, there is an exchange in the amount of heat. Okay. When hotter bodies involved with colder substance, heat transfer takes place from hotter substance to the colder substances until the mixture or both the substance acquire the same temperature. So heat transfer will be occur when until the temperature will be same. Both temperature will be the same. Heat lost by the body at the higher temperature is equal to heat gained by the body at lower temperature. So heat lost by a hotter body is equal to heat gained by a colder body. Okay. Hence the total amount of heat of the component substance is equal to amount of heat in the mixture. So hence the total amount of heat of the component substance will be equal to the amount of heat in the mixture. So you can write this equation. Heat lost by hot substance is equal to heat gained by the colder substance is equal to substance. It means substance of the component amounts of heat is equal to amount of heat in the mixture. So there is a two volume that will be two any liquid you are mixing with both you are mixing. One liquid is there with the M1 mass, S1 specific heat, the temperature T1. When another liquid M2 mass, S2 is the specific heat, T2 is the temperature. When you are mixing, what will happen? M1 S1 plus M2 S2 into all into T temperature of the mixer. This equation will be satisfied. Okay. So one problem is there. A bath tube containing 40 liter of water at 15 degrees Celsius and 80 liter of water at 60 degrees Celsius is poured into it. So a bath tube, one tube is containing 40 liter of water at 15 degrees Celsius. Temperature is 15 degrees Celsius and 40 liter. Okay. In that bath tube, we are adding 80 liter of water 60 degrees Celsius. So see, a water of 80 liter water with a 60 degrees Celsius, we are adding to that bath tube. Okay, what is the temperature of the mixture? When you are adding that one, what will be the next mix temperature of the mixture? So you have to apply this equation: m1 c1 s1 t1 plus m2 s2 t2 is equal to m1 s1 plus m2 s2 into tm. So what is the m1? 40 kilogram. Okay, so 40 liter means 40 kilogram into a specific heat of the water is equal to 4.2 kilojoule per kilogram Celsius. Okay, degree Celsius into the temperature will be the 15 degree. Okay, the temperature will be 10 degrees. Then what is the m2? M2 will be the 80 liter, that will be 80 kilogram. We are at 80 kilogram into the what is specific 4.2 divided into what is the temperature 60. This will be equal to m1 s1. 40 kilogram into s1 will be the 4.2 plus, there is a no term here. Okay, the next one is m2 s2. M2 is the 80 kilogram into what is the specific heat, 4.2 kilojoule per kilograms into tm, that you have to find. Okay, so when you're adding this one 14, this value you will get the 22 for 22,680 value that you will get. Okay, divided by this value, you have to find tm. So this divided by this value, you will get the tm. So when you're 4.2, it is a common, you are taking the outside. 4 plus 80, 120. 120 into 4.2, you will get the 45 degrees Celsius. So when 15 degree water and 60 degree water you are adding, what will be the mixture temperature? It will be 45 degree Celsius. So this is the last part and last video of this chapter, heat and temperature. I think everyone is understood my classes. Thank you for watching this video. Thank you.